Hi, today I'm going to present about the lab in electronics engineering. Uh, it's called machine vision, and the topics of uh, the, this lab is for uh, the Sudoku problems. Okay, my name is Kan So, by the way, and the objective of this lab is to extract the numbers from a 9 by 9 matrix of the Sudoku and by using the MATLAB. Okay, so the algorithm that I use here is show here. Uh, I will talk about it in detail in the next slide. Okay, so first I convert the picture into the color picture into black and white. Okay, so to do that, I use a bilateral filter. So it's just to blur the image a bit, so the noise can be a bit lower, and when you change it to black and white, it doesn't get uh, sprinkle with dot everywhere, something like that. Then uh, I convert the color picture into the gray scale. Then I spread the distribution. I use the function called im adjust. Okay, im adjust and to adjust the distribution so that the lower and the upper uh, bound, the minimum and the maximum has 1%. Okay, uh, 1% of overall uh, uh, distribution. Then I convert the gray into black and white by using the uh, average to set the sensitivity of of the uh, threshold. Okay, here is the example of what the result could look like. So in the first image is the input, and then uh, the the grayscale that convert from the input image doesn't display here, but when it's spread out in the distribution, you can see on the center, and then uh, compare, okay, to the threshold to get black and white. It's on the right hand side. This is uh, how the distribution work. Okay, so you can see uh, first first image. So when the leftmost image, the input image converted into the grayscale, not the center one, uh, you can see it's very at the center, and uh, the uh, the converting cannot convert the grayscale into the black and white uh, very effectively. So I spread the the distribution out, so you can see it's uh, ranging between 0 and 255. Okay, so when we got the black and white image, we filter it by the largest area, so we can get the uh, the grid of the Sudoku. Here this line will be a grid. So the grid will then uh, going into the peak of grid detection, and also to the to fit the image to the grid, so we can extract each of the number in the grid. Okay, so here is the black and white image, and when use the image sort by filter by size, filter by size, we can get the and the maximum number of maximum the largest area uh, is the grid. Okay, now we get to detect the peak here. So in order to detect the peak, uh, we did sum the x-axis and y-axis as shown here. So you can see on the blue line, it will be the summation, and this is respect to x-axis. So if we go back here, you can see x-axis is that's spread out uh, uh, like edge to edge, but from the y-axis here you can see the bottom is left out, and as you can see the x-axis is also spread out widely, and but the y-axis is go to 0 after a bit here. Okay, so to detect the peak, you can see the blue line has a very high uh, fluctuation like this one, so I filter it out. And the grid is also not very low frequency, so sorry, not very high frequency, so I can use low pass filter to filter the noise out. And you can see I use orange one and the yellow one because sometimes it's it's just like here you can see the blue one will fluctuate a bit, and that's cause the orange one to go up a bit, and that its detect is it as a peak, but I don't want it, so I find the average between there. So I know that uh, between here it's it's very low respect to the peak around here. So to uh, find the average of the very large number here, and uh, use the peak from this one, and detect that this peak must be higher than the low frequency one. Yeah, so that is a peak. That is an actual peak. Same thing on the y-axis. On the y-axis, you can see the fluctuation very clearly here. So the next thing will crop the image to fit the grid, and uh, then extract each of number to the grid from the grid here, and also delete the grid, because when we divided the grid into a grid into that smaller square, uh, some of the grid will uh, mess with the image, the character recognition, uh, the optical character recognition, OCR. Yeah, and it's very annoying. So I delete it by use here is the white is 1 and the black is 0. So here I use the logic OR to get this one, and this is 0. So 1 or 0 is 1. So you get white, and then you get without the grid. Then I divided it into 81 grid. Okay, and you can see there's no grid here, so the OCR can be detected. It's very easily now. As you can see, the algorithm is uh, pretty good at detect the the number. In this case, it's 100% correct, but not always. Here is the I use the OCR. It is a built-in function in the MATLAB. It's add-on, yeah, in the image processing toolbox, I guess. And then I solve the Sudoku, but this one is so hard. The my algorithm that I writing is not capable of solving it. So there are more results. Here are input on the left, and what it can extract is on the center, and when it's solved is on the right. So the first example of the wrong detection is here 8, and it's read out as 5. I checked the image that it's is on the grid here. It's very clear that it's 8, but the OCR of the MATLAB thinks it's 5, so I don't know what's going on. But yeah, um, but here on the both is uh, it's okay. It's detecting all right. Here's another one, 8, and uh, it's also appears on the grid, but it can detect the 8 also. And um, yeah, okay, this one looks okay. Yeah, it can solve fully here. So thanks for listening.